Hi, ma'am. This is Lara Sushmitha from Section C. My topic is properties of light. Light means electromagnetic radiation that can be detected by the human eye. Some properties of light: effects of materials on light, reflection, refraction, dispersion, total internal reflection, interference, diffraction, scattering of light, and polarization. Effect of materials on light. Materials can be classified based on how it responds to light instead on them. Opaque materials. It absorbs light, do not let light to pass through it. Transparent materials are the materials allow light to pass through them. Translucent materials. It allows light to pass through but distorts the light during the passage. Reflection. Reflection is the phenomena of bouncing back of light in the same medium on striking of the surface of an object. Light follows the law of reflection. The angle of incidence is equal to the angle of reflection. Light can bounce off materials in two ways: diffuse reflection and regular or specular reflection. Diffuse reflection is reflected rays go in different direction, happen in through textured or uneven surfaces. Regular or specular reflection. Reflected rays go in one direction, happen in smooth and shiny surfaces. Images can be seen. Refraction. Refraction is defined as phenomena of change in the path of light in going from one medium to another medium, or light bends or refracts when it changes speed. This usually happens when the light travels from one medium to the next. Simple rule of thumb in reflection: if light slow down, it will refract towards the normal line. If line speeds up, it will refract away from the normal line. Light travels faster in air, slower in water, and slower still in glass. The slower light is in a medium, the more it refracts, bends in it. The measure of how much light refracts in a medium is called index of reflection. In air, 1.00293, water 1.3330, glass 1.490, and diamond 2.419. Dispersion, the process in which light is separated into colors due to the differences in degree of refraction. Example is rainbow. Rainbow is formed by dispersion of light. Total internal reflection, when light is reflected completely at the boundary between two mediums, and that is how optics works, and diamonds get brilliance due to the total internal reflection. Diffraction, light spreads out after passing through or by opening or edge. Opening must be very narrow for diffraction of light to occur. Interference, light can superimpose and have either constructive interference or destructive interference. Some light is a wave, and its properties, wave properties are diffraction. This is defined as the bending of light waves around obstacles in its path. Example, when a light wave passes through a barrier with a small opening, it acts as single point source from where it emerges and spreads in all direction. So, Light is a wave or a particle, means light has dual nature. Depending on the phenomena or a behavior in question, light can be treated either as a wave or as a particle. To examine this wave particle duality, we will examine two experimental proofs. Light is a wave is given by Young double slit experiment. It is conducted by Thomas Young in early 1800s, provided an experimental basis for considering light as a wave. Young double slit experiment is the individual slits acted as individual sources which light passes through and spreads. Light exhibits interference, which is a wave property. Light is a particle is given by the photoelectrical effect. It is explained by Einstein during 1900s, provided an experimental basis for and considering light as a particle. Einstein earned as Nobel Prize for his explanation. Photoelectric effect. Higher energy light knocks off electrons at higher energy. The number of ejected line electrons is directly related to the intensity of light. This means brighter light emit more photons. Light is a particle since it is capable of knocking off electrons. Further, unlike waves, increasing the brightness does not increase the energy of knocked off electrons. Thank you, ma'am.